velocity time graphs. So if you do physics, this should be familiar to you. So velocity on the y-axis, time on the x-axis. On this diagram, there's actually a line over here. That is a line. So that represents an object which is traveling over time, is traveling with velocity 0. So obviously, if the velocity is 0, then the object is not moving. So if the object is not moving, we say the object is stationary. Okay, so that's velocity 0. If you've got a horizontal line somewhere else, so here the object has some velocity, and the velocity is not changing, so the velocity is constant, then you just say the object is moving with a constant velocity. Okay. So if an object is moving with constant velocity, the velocity is not changing, that means its acceleration is 0. So that also represents a equals 0. Acceleration is 0. Okay, third situation, if the velocity time graph is just a straight line, that means the velocity is increasing at a constant rate. That means the velocity is increasing. So it also means that the acceleration is constant. So you can also say a equals some constant. So the key features are, in a velocity time graph, the gradient tells you the acceleration. So you can calculate the acceleration of the object by calculating the gradient of the line. Also, another key feature is that the area underneath the velocity time graph represents the distance traveled, tells you the distance traveled. It says here, the area underneath the velocity time graph represents the displacement. So the area tells you the distance, basically. So is that familiar to some of you, that idea? Okay, so this is the first example I've got. So they've drawn a velocity time graph. Motion of a cyclist moving along a straight road for a period of 12 seconds. So that's the end time, 12 seconds. For the first 8 seconds, she moves at a constant speed. If it's moving at a constant speed, it's just going to be a horizontal line for the first 8 seconds. So that makes sense. 6 meters per second is on the y-axis. Okay, then she decelerates at a constant rate. That means her speed is decreasing. And then she stops after a further 4 seconds. So she stops, that means her velocity is 0 after a further 4 seconds. So 8 plus 4 is 12. So the graph touches the x-axis after 12 seconds. Okay, so that's the completed velocity time graph. And you need to find the displacement from the starting point after this 12-second period. So the displacement on a velocity time graph can be calculated by just working out the area underneath the graph. So to work out the area, you can do it as a rectangle plus a triangle, or you can just do it as a trapezium. So remember the trapezium formula, half a plus b times h is the area of a trapezium. So for part A, to work out the distance traveled, so they use the letter S for displacement. You would do half of, so the parallel sides are, so this is 8. The other parallel side is 12. The distance between them is 6. That's the h. So that's equal to 60. And the units are in meters. So that's the area. So that's the displacement of the cyclist after 12 seconds. That should be no problem. Part B is work out the rate at which the cyclist decelerates. So the deceleration, you need to look at the gradient. So the deceleration occurs on this part of the motion. So you just need to figure out the gradient of that line. So you can see that the gradient, the rise is 6. Okay, well, strictly speaking, okay, it's -6. You can do it as coordinates if you want to. Okay, if you want to work with coordinates, that point would be 8, 6, and the end point will be 12, 0. So when you work out the gradient, you could do 0 take away 6 over 12 take away 8. So we know it has to be negative. So that gives you -6 over 4, which is -1.5. So the acceleration is negative because the cyclist is slowing down. But the question is asking you for the deceleration. Okay, so that means the deceleration is 1.5. So you would say the deceleration is the rate at which the cyclist is slowing down is equal to positive 1.5 meters per second squared. So deceleration is always a negative acceleration.